understand about the lecture notes I upload here, if you enroll in my course, you will have access to this lecture notes, and you can have it, brings it out to you for you to understand better as well, examine it, and that's how we learn online. Okay, so here, the limit of the function, basically, when we're talking about the function, we're talking about, we pay attention to any points of the function, right? So if I pick up the point is here, the x value of this function is 10. And the y value of this function here is 5. And the scale depends on whatever problem I want to demonstrate it. So in here, I make the scale is 10, 20, 30, right? Now, in another problem, you might make this scale is 1, 2, 3, 4, 5. And if you're talking about the investment of your money is go up to 100,000, you might scale this one represent 50,000, 10,000, or maybe 5,000, 10,000, right? So anyways, the scale of x and y can be different as well. So for example, here I make 10 and 20 for x, but I make 5 and 10 for the scale of y. It doesn't matter. Sometimes you might make them the same, sometimes you might scale them differently, depend on the problems. Now, let's look at the limit here. So when we're talking about the limit, basically, my definition about the limit is just what is the value of y when the x-coordinate approaches to the value of 5 or approach to the value of -6 or -8, right? Now, the word approach means it's not exactly, but it's close. It's very close, very close. It could be 6.999, and that is like round off, become a 7, or maybe -3.00001, and we just say, oh, that is a value of 3, right? So the word approach means not exactly, but it very close, right? So now, basically, limit is, at any point of the function is, what is the value of y when its value of x is 5 or 6 or 7 or -100, right? So basically, that's the limit, okay? I don't want to make it so like abstract and so difficult, right? Let's just focus in here. So on the bar, I wrote 5, the limit, right? The limit of f of x. And I put the notation is LIM here of f of x. The notation in mathematics is very important. If you don't put the notation, sometimes it doesn't make sense. Even though the negative or positive become a very important. So you got to pay attention to a little bit details and tedious tasks for math. If you omit on of the size or on of the notation, sometimes you make math become nonsense, right? And therefore, I strongly advise you never skip any notation in mathematics. Write it down, and so it makes sense, to make math make sense. So we're talking about limit, LIM, f of x, when x approach, when the value of x, let's say approach to 10, right here. And in my lecture notes, I explained to you that to define a value of limit, because sometimes limit exist and sometimes limit does not exist, right? And if the limit exists, how do we prove it? How do we prove the limit of the function exists at that particular point, right? So at particular point when x approaches to 10, what is the value of y? Right? What's the value of y? So to find this and to prove this as it, we have to look at left-hand limit of f of x, right? So we look at left-hand limit of f of x, and left-hand limit when x approach to 10, and we put the notation minus 10 on the top right corner of the number, which is left-hand limit. So if we talk about the left-hand limit, then we have to look at the function at that point, but on the left side of the function, which is this part, right? This part of the function, okay? And we look at this point, when x here, from 0 approach to here, this level, right? So look at here, on the left-hand side, that we call the left-hand limit. The value of y right here, look at the value of y right here, I mark as 5. So the answer for this is limit of this function, left-hand limit equal 5. Now, when we look at the right-hand limit of the f of x, when x approaches to 10, on the right-hand side, we put a positive on the number 10, and we also look at where the function approaches right here. So it means very close to 5, but it might be 5, like maybe 4.99999, right? We also say this is 5, right? So the function approach, the y value of the function approach to 5 when x approach to 10 on the right-hand side. Then we compare the left-hand limit and the right-hand limit. We say, the left-hand limit of this function when x approach to 10 is 5. When x approach to 10, on the right-hand side of the function, the value is also 5. So we conclude that, therefore, the limit of f of x when x approach to 10 equal 5, right? And that's how we prove the limit exists, because to look at the limit, whether or not it exists, you have to look at the limit from the left-hand side of the function to that point and the right-hand side of the function to that point. And if they are equal, you say, therefore, its limit when x approach to 10 equal 5. And they said, how do you know? You will say, oh yeah, I know, because I look at left-hand limit and right-hand limit and I know they're equal. So how I prove it? Okay, simple. Now, let's look at the next example. So now my question to you, what about limit of the same function f of x? But when x not approach to 10 anymore, but when x approach to, this is minus 10, right? This is positive 10, this is minus 10, this is 15. So minus 15. When x approach to minus 15. Again, you always look at left-hand limit and right-hand limit. So when x approach to minus 15, right? If you look at on the left of this function, you encounter an asymptote in here, and it means that on the left of asymptote, right, this function does not exist. If it does not exist, then how can you find the y value? How can you find the value of the function? Because it's not there, right? Nothing. So on the left-hand side of this function, you can say that limit of this function when x approach to minus 15 on the left, it does not exist. There's no function for you to find. Now, what about limit of this f of x when x approach to 15 on the right-hand side? So when x approach to 15 on the right-hand side, yeah, we have a function, right? But it stopped right there. It not cut through the asymptote. So it go up, 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 up forever. So the limit, this function is infinite limit, right? It doesn't have any value. This function keep going on top, up to positive infinity, right? Up to positive infinity, okay? So this function keep going, grow up to positive infinity, And therefore, you will say limit of this function when x approaches to 15 on the right-hand side is positive infinity, right? It up this way, it's not down here, but down here you call a negative infinity, but this one is go this way direction, positive infinity. So what is your conclusion about this? Do we have a limit here or the limit does not exist? So then your conclusion is, therefore, limit of f of x when x approaches to 15 equal or does not exist. D and E represent for does not exist. It's a short form for does not exist from now on, okay? So this is how you make observation of the function and you find the limit of this function based on their graphs. Now, let's look at the second graph down here. Okay, so let's say if I ask you about the second graph, and this function I call it g of x. So what is the limit of g of x? When x approaches 2, let's look at this point right here. This point right here, this point is 1, 2, 3. So this is about 3.2, right? The x is about 3.2. So when x approaches to 3.2, what is the limit of g of x? So you look at on the left, right? On the left from this point and go this way. What's the y value of this function? So the y value can be here, go here, right? If the y value go here, it's equal minus 1. If it go here, it's minus 1.5. Go here is minus 2. So at this point, when x approaches to 3.2, on the left-hand side, the limit of g of x equal minus 2. Minus 2. So that's how we look at, and this we call a left-hand limit. Left-hand limit. Now, if I talk about left-hand limit, I should have a negative on the top for this number, right? So now let's look at the limit of this function when x approaches to the same value, 3.2, but it's on the right-hand side. So positive on the top. So now you look at, this is the function, right? So look at this part. It's approach to, now if I don't make this is the dot point, darkened point, but the empty whole circle. Let's say it's empty. It means right here, the function, the value of y does not exist. It's broken, it doesn't have any value. However, does this limit exist? What is the definition of limit? When we're talking about limit, we say, what is the value of y approach to, the function approach to, when x approach to that point? And the word approach to you mean it closer, it's very close, but it's not right exactly. And therefore, regardless the darkened point or the empty circle here, broken, and sorry, I have to show you, right? Okay, so now you can see it. At right here, if it is empty, it's a hole, the value of y is, yes, it's still minus negative because it's like 1.999999, right? So minus 1.9999, so almost like minus 2. And because we're talking about approaching, it doesn't have to be exact, but it's like very close, getting so close, right? So what is the value of x at 3.2 when the value of, what is the value of y approaching on the right-hand side? The value of y get close to minus 2, right? So we say on the right-hand side, it's get to minus 2. So we look at the left-hand side, the function approach to minus 2. On the right-hand side, the function also approach to minus 2. Therefore, we conclude, therefore, this limit, and you write like that, f of x, when x put underneath this, approach to 3.2, right, will be equal minus 2. And what is the reason? All what you have to do is, reason is left-hand limit equal right-hand limit equal minus 2. They both approach to, they both the function of y both approach from the left as well as the right approach to -2, right? Down here. So that's how you find the limit on the graph. Again, you can see that based on only 2 of this example, I can show you that sometimes limit at z and sometimes limit does not at z. So